Impulse commutation is the one of the type of forced commutation. This is the impulse commutation circuit with main circuit. The source Vs flows through thyristor T1 and gives the current Im to the load. To turn off this thyristor, we have an additional circuit with the capacitor, and initially the capacitor is charged to minus V0 and the polarities as shown in the figure. When T2 is fired, capacitor C starts discharging, and the capacitor would carry the load current. Due to this, the thyristor T1 turned off as the reverse voltage is applied to the thyristor T1. Here, thyristor T1 can be considered as the main thyristor and T2 can be considered as the auxiliary thyristor. Now, the capacitor starts discharging its voltage from minus V0 to 0 and then charges to DC input voltage Vs. When capacitor voltage becomes 0, at this time the thyristor T2 turns off. To make this capacitor to come to the initial position, the thyristor T3 is triggered. Now, when you closely observe this part of circuit, it looks like a self-commutated circuit. Now, please go through the topic self-commutation. The link is given in the description below. When you turn on the thyristor T3, the voltage across the capacitor will come to the initial stage and then T3 stops due to a self-commutation. The thyristor T1 is commutated by using the auxiliary thyristor. So, this is also known as auxiliary commutation. While turning off the thyristor T1, the reverse voltage is applied. So, it is also known as voltage commutation. Now, at the initial stage, the capacitor voltage will be minus V0 and it will stay at minus V0 until T1 is on. At this point, T2 is turned on and T1 is off. Then it starts discharging to 0. At 0, T2 turns off. The voltage charged to Vs. And the time taken to discharge from minus V0 to 0 is known as circuit turn off time T off. And at here, T3 is turned on, the voltage comes back to minus V0 and the self-commutation takes place, T3 turns off. This is an equivalent circuit for the impulse commutation circuit. The time required for the capacitor to discharge from minus V0 to 0 is called circuit turn off time and denoted with T off. And this T off must be greater than the TQ, which is nothing but thyristor turn off time. You can say that T off is the available turn off time. The discharge time will depend on the load current, and assuming a constant load current of Im from the circuit, V0 equals to 1 by C integral 0 to turn off Im dt. So we'll be getting Im T off divided by C. Now the T off equals to V0 C by Im. Now from this equation we can say that circuit turn off time T off is inversely proportional to the load current Im. So at light loads, which means low load current, the turn off time will be larger, and for high load currents the turn off time will be smaller. But in ideal commutation circuits, the turn off time should be independent of the load current in order to guarantee the commutation of the thyristor. So the discharge of the capacitor can be accelerated by connecting a diode and an inductor across the main thyristor as shown here. So determine available turn off time, that is T off. The given data is Vs is 200 volts, R is 10 ohms, C is 5 microfarads, and the V0 is equal to Vs. For the impulse commutated thyristor circuit as shown there. For this figure, the voltage Vc is given by 1 by C integral I dt plus Vc at t equals to 0 and Vs equals to Vc plus the voltage at load, that is IR. At initial stage, Vc at t equals to 0 is equals to minus V0, which is nothing but minus Vs. For this equation, the solution by using the initial conditions, Vc of t equals to Vs 1 minus 2 e to the power of minus t by RC. The turn of time T of equals to RC ln of 2. And substitute in this, then you will be getting 10 multiplied by 5 to 10 to the power of minus 6 ln of 2. Now when you calculate this, you will be getting 34.7 microseconds.